All right, so let me introduce Meghna. Meghna is the VP of AI and data. You had the AI center?
AI only.
AI only. Sorry, data is your peer, you told me. So why don't you tell us a little bit about your role at Verizon?
So I head up AI at Verizon, and before I talk about my role, like we're a little bit on this AI and data journey. And about 3 years ago, Verizon as a company, as a telco, right? Like it's one of the biggest telco in the world. We use data, we use models. So it's not like we just got started. But about 3 years ago, there was a mandate to centralize these functions and think about these as enterprise capabilities. So that led to the formation of my boss's job. She's the CDO at Verizon. And so she started like looking at data engineering, platform engineering, AI, and a bunch of data governance, like a whole bunch of functions. So within that, I sit as the head of AI. I was hired. I was at Target at that point doing data science, machine learning for about a decade at Target. I was hired to set up the AI center at Verizon. And Verizon as a company, so it's about $135 billion annual revenue, and 100 of that is consumers, like you and I, our cell phones. About 35 is the business consumers, business accounts. So it's a fairly big company, and we actually run the consumer and business, kind of like as two independent organizations. Then there's a network organization. We work with all of them, so like those are the three biggest part of the company. And that's what I mean, like we're a horizontal capability. We are, what it means is that we want to standardize how we do AI at Verizon. So we pay attention to governance, we pay attention to model architecture, responsible AI, those kind of things, like making sure that we have the right checks and balances for bias mitigation, things like that. So that's what I'm standing up. It's been 2 years. I'll talk more about how we are thinking about it and what that entails. But the scope is pretty vast. It's the whole company.
So you sort of alluded, so talk a little bit more about sort of the horizontal capability that you're building. I know you told me that your core principle is build once, use many times.
Yes, yeah.
And you're creating a reusable model and infrastructure. So expand on that for us, if you will.
Yeah, so we recently did this presentation for our leadership at Verizon, and we said, let's give you a tour of the factory. The only thing is the factory is invisible, right? Like we said, here's a data factory, here's an AI factory. So we talk in those terms. We literally have, details of like how we take hundreds of source systems, we harmonize the data, we create data fabric. That's not me, that's data engineering, that's my counterpart. And then I talk about the models. And what we've done is we have hundreds and hundreds of models. Like we have a pretty mature forecasting and optimization practice because we spend billions in infrastructure, right? Like so how to deploy, how to build the network, how to plan for all the workforce that will build the network of the future, how to plan for the workforce that will manage the network. We have pretty extensive retail presence, 2,000 stores. We have huge call centers, all of the workforce that we have. So forecasting and optimization is a very important function. And so what we did is we had hundreds of models doing workforce optimization for about 80,000 of our workforce. And we looked at all of that, and we said, we cannot run so many models just independently, right? Like even with a centralized team, you can have all kinds of mistakes and all kinds of issues. So we actually like completely standardized 80% of the code and put them under 3 model archetypes. Sorry, I'm just going to get a little bit more technical, but what it means is that if you're forecasting call volume for field technician versus call center, it could be the same model. You don't need to have like separate like pipelines of that stuff. So we just started like looking at commonalities, and we found that of 300 models, you only needed 3 archetypes. And we just, and that's what we say, like we've created model architecture, just like some of these neural network models have, but for more traditional forecasting. And we've just completely standardized the pipeline for that. So
give us, you mentioned sort of workforce optimization as a use case. Mm-hmm. What are some of the other use cases that are really important to you at Verizon?
Yeah, so the other 2 that I talk about, and I'll try to stay brief, but like it's a ton of work, but I'm excited about is personalization. And like to me, personalization is is at the heart of every experience that you should have with Verizon. We do it okay, but we have an opportunity to do it for your entire journey. So if you call us, if you're new to Verizon, if you're upgrading, for some reason you're downgrading. So making sure that when you contact Verizon in the context, in that moment, we are helping you with exactly what you need. So it's again, they're algorithmic real-time predictions, and again, using common model infrastructure to do that, because again, how we personalize your experience in store versus our app versus call center, we do it, but they're not connected. Mm-hmm. So as a customer, you don't feel like you're getting the same, that contextual continuity if you called us and then you went to a store. So we're working on personalization. That's actually, literally, I spend most of my time.
So give us a couple of examples of personalization. So I show up, and what does the system know about me, and what kinds of things does it predict?
Yeah, so I think, so first it starts with what we are allowed to know about you, because mm-hmm. as a phone provider, a lot of data is available, but it's also heavily regulated, right? If, let's say we have access to your information, you've opted in and all that, then I know that you call the call center, so I know that information. So when you walk into the store, I should help you with that. Or if you looked at some accessories online, and so that where you dropped off digitally and pick up in retail, right? Is what we're working towards. And by the way, my work at Target was at the heart of omnichannel, so it's it was exactly the same thing. It's when people don't think about, am I shopping on an app versus website? They're I'm shopping with Target. Make it work. Make it easy, make it work. So it's the same principle with personalization here. The other one I'll mention briefly, but it's a conversation in itself, is digital twins. So the network is evolving, right? We are investing in 5G. We're investing in broadband now. We are starting to go into homes, and everybody's going to go, and with mobility, people don't want to deal with when we're all on calls, if you're in a call using your Wi-Fi, you walk out to walk your dog, your call drops for a few seconds, and that handoff happens. All of that is going to go away in a few years, right? It's the network is going to become seamless. And in that situation, the network has to be self-optimized. It has to be a learning system. It has to be self-healing. And so we've been investing in digital twin technology, which means that we're basically building the digital replica of the network so we can manage that much more effectively and efficiently, and not just through human resources and field technicians and things like that. We'll always need that, but again, inserting automation in network management, network maintenance, things like that. So digital twin is going to be pretty revolutionary.
This is a great example, because usually when we talk about digital twin, we're talking about an aircraft engine or a factory or things. And sort of your use of really what we're talking about is simulating digitally, and I think increasingly you can simulate pretty much anything.
Exactly.
I think you even talked about retail stores and sort of simulating sort of where these should be located.
Exactly. So digital twin, you're right. People always think about turbine engine because GE has been doing it, NASA has been doing that kind of stuff, it's physical modeling. But with compute becoming cheap, algorithmic simulations are cheaper. We're just talking about if we can just recreate the network experiences with all the performance data we have, then we can simulate all the possible issues you can have, and we should be able to predict based on that and proactively help people before they ever reach out to us. So it's numbers and data. You can still simulate the physical modeling stuff is cool, but this is actually much more cost effective, actually.
Yeah, I can imagine that. Yeah. So the future is both exciting and a little bit.
There's always the balance. There's always that. We have to, do it responsibly, right?
Yep.
We have to learn to do it responsibly.
I think some of us just said, what, everybody knows everything about. When I moved to this country, it was sort of interesting because physicians would never put their phone, their name and addresses or phone numbers in the phone book because they didn't want to be called at home. Mm-hmm. And people would and so now it's it doesn't matter who you are, that mm-hmm. information is all public. Let's switch to, part of this is not just about the use cases, but a lot of companies are trying to build AI capability.
Yeah.
And you've obviously done it now, or in the way of continuing to do it never ends. How do you think about this AI unit that you run? How is it organized? How do you partner with the data engineering teams, things like that?
So first of all, I think I mean, I don't have experience with smaller companies, so I probably am not the right person to talk about it. But, both at Verizon and my target experience was about scaling. And because these things work in a small project, but if they don't scale, for a big company, it's really just a science project, right? It's really important. I'm a big believer in functionally aligned orgs. So I wanted to make sure that, the data scientists that are hired are the best and they're the specialist. So they're not doing data science and machine learning engineering. Sometimes in personalization, the lines are blurry, but we try to create clear lanes for people, where the accountabilities end and finish. And that's why our organization, we have platform engineers, data engineers, then the AI ML engineers, and the data scientists. We also have data architects because we are generating more data than we can consume. So we also need somebody to think about how to organize all of that and put that in consumable fashion. So we've been very big on the functional way of organizing. But with functional, people have to learn to work in matrix and pods. So integrated team that are organized by pods is how we work. That means that, if I want to do personalization, I've got 20 data scientists, 20 MLEs, and so you have to kind of assemble that and make sure that you make the case. So there is some art to that, but I found that is more successful in both.
So the pod approach is working?
Yeah, exactly, yeah.
I think that's, because we sort of bundle all these things together without thinking through sort of oh, AI is so cool, it can do all of these things. But there's a real sort of workhorse element to AI, which I was alluding to in my talk this morning, which is there's all these complementary things you have to be good at: data engineering, AI. Which leads me to sort of a question, where do the genius ideas come from? When you start, where, there's, yes, we know how to forecast this, and we can, but this, every now and then you want this breakthrough whiz-bang thing that says, oh my God, I can do this. Is there a capability where you're trying to spot the big moves?
So I have 3 points on that. So first is, I'll give a target example because that's now approved. When I used to talk about it, people didn't get it, but now it's proven, so I want to share. Because that idea came from somebody on the team. I don't even know that person's name. Even the CEO was against it. It was pretty disruptive, and we said, let's just test it out. That's all. And the idea I'm talking about is the service called Drive Up. Most of you might have used it in the pandemic. Nobody wanted it because a company that's based on physical retail store, you're going to get people to drive to my store and not come in? That's just completely contradictory. And so it came from these working pod kind of teams because they were in the data. They were, running hundreds of experiments. And somebody on the team said, what if we had a drive-up service for the busy mom after a soccer game because she just wants to pick up stuff. She doesn't have time to go through 20 aisles. And, like I said, stores organization wasn't in favor of that and all that. So I fundamentally believe that if you organize these groups of people, they will solve problems better than us more experienced people because they will see these things and you want them in that environment. I really believe in that. I've not led R&D type of organization, so I'm not trying to say that R&D is not needed, but most of my work has been in commercial application, and in these commercial environment, you have to live and breathe in the domain where you're trying to solve the problem, and you just have to empower those teams, and somebody will come up with something. That's where I've seen most success, and this is just one example, but there were many during the transformation phase at Target, and I'm starting to see at Verizon, when we started talking about digital twin, my thinking on digital twin was actually fairly limited, and somebody on my team actually educated me. Privacy, because of telco, is another one. You think okay, how do I get around privacy? And I just recently learned about differential privacy, where you never have to know the identity of the people, and you can still do a lot of work with it. So basically, you know people in groups, but you don't know them individually, and you don't know their preferences. So, the teams are just smarter than you if you just empower them, has been my experience.
It's funny that you say that because talking about curbside pickup, I don't think I'd ever done curbside pickup before the pandemic.
Yeah,
And
nobody did. Yeah.
And I'm still doing curbside pickup.
Yeah.
I just thought this thing is such a wonderful model.
It
It's
shot up their
why
stock
would I
price,
I mean,
like,
it's not that we don't
significantly.
go into grocery stores, but
Yeah.
it's just like, okay, if I can save an hour by not doing this, why not?
Yeah.
How many people in your AI group?
So my AI organization is about 150 people. So that's just like, so there are data scientists in other parts of the company, but I call them hardcore data scientists, like the real deal, difficult to get. So that's my organization, and we sit in that AI and data organization, which is my boss. That's about like 900 people of engineers, architects, product managers, and data scientists, like all of those functions together.
So since this panel is called Investing in Frontier Technologies, let me ask you the final question, which is about investing. How do you actually make the case for technology investment in AI at Verizon?
So how do we do it?
Yeah.
So we actually, we line it to business priorities. So we will look at, like, for example, right now we are actually, looking at pretty significant transformation on our consumer side. And so there are investments in digital transformation, and within that, there is we want to simplify our price plans. We want to simplify the experience. And every time, when I look at it in my mind, oh, that's personalization, that's personalization. So then I've created a use case of okay, all of these are requiring some same flavor of models and data and, ecosystem. So I'm going to need this. So we ladder it up to those investment priorities. So that's probably the easiest and fastest way to get that. The other thing we do is we also make sure because we're a centralized organization, so we tap into these business initiative funding, but we also have horizontal funding. So we can also do some, self-paced stuff. So it's a combination of both.
That's all I have for you. So we're going to bring her back onto the stage to ask questions of, but in the meantime, let me invite Kiva onto the stage, and then we'll bring them both up together so you can ask questions.
Fantastic.
Thank you, Meghna. I really appreciate it. So the next time you go into a Verizon store, and if they know what you want, thank Meghna. If they don't know what you want, don't thank Meghna.
Don't send her an email.
Go put the pressure on. Get those AI models right. Okay. Welcome, Kiva.
Thank
Kiva
you.
is on my advisory board and the CEO of Sarcos, a robotics company. She's had a storied career at GE and I think Qualcomm before GE, if my memory serves.
Yeah.
So fascinating company. I'd honestly not heard of Sarcos until Kiva tells me she's becoming the CEO.
Yeah.
Oh, you were at Ericsson too. I forgot that.
Yeah.
I moved to Sweden for that. So let's just get to the straight question, which is, what sort of robots does Sarcos actually build?
Yeah, great. So good to see everybody. Sarcos has 3 product lines. We've got an exoskeleton, which is exactly what it sounds like. A human gets inside and it increases its lift capability. It protects it from, if you think about jobs that have a lot of stress on the different parts of the body, it alleviates that. So it's a powered exoskeleton. The other category of products that we have are teleoperated robots. So we really thrive in unstructured environments. So unlike robots that people think of today, you're thinking, say, a robotic arm on a factory floor that does the same task over and over and over again, and it learns that often by using AI and machine learning. We work in environments such as an airport or a tarmac that looks different every day, or a construction site. At least you hope it does, right? Because that means things are moving and the construction is happening or the planes are taking off. And the last product that we have is actually software solutions that really package up autonomy and other services targeted at, hey, I want to teach a robot how to learn. So we do a different type of training. We do what we call success-based learning. So human is still in the loop, but the human shows the robot what to do, and then in a very simplistic terms, then it says repeat over and over and over again, so that it can pick a plane or an area and really teach the robot how to do it. And then the human is still in the loop, but it can do what we call supervised autonomy. So that's our software package on top of the 2 different types of robots.
Fantastic. So tell us about, we talked about many use cases. If you could talk about your top use cases, I think you talked about de-icing, cleaning ships, the hulls of ships, and then baggage unloading from a plane or loading.
Yeah, I mean, I've been doing, I would say, digital transformation almost my entire career. So I started off as an IT consultant and really worked at the back end, connecting systems. And through that process, I've learned that every time you sit down with a customer, rarely do they ever say, I'd like to use X technology to do Y. They typically say, hey, this is my biggest pain point. So when we sit down with partners like Delta and one of the largest airports in Europe, their biggest pain point is the fact that humans can't go on the tarmac in an electric storm, right? So what does that do to them? Well, it basically ruins the productivity for the day, right? And also the customer experience isn't very good because you've been sitting on a plane for 35 minutes. The doors are closed and you can't understand why you can't take off. Well, that's because a human can't walk out there and do one little task, but a robot can. So because of where we focus, these are highly dexterous robots, so we have the same functionality as a human. The person can sit in the cab, use the dexterous arm, unlatch it, take the water out, and off the plane goes. So if you think about really where we're focused, it's on dirty and dangerous jobs. So some of our partners, they're sending people in places they really shouldn't. You'd be surprised by some of the places I've been. And some of the situations we truly are putting people in on a daily basis. And there's really no reason that we need to. So our vision is to increase productivity and worker safety at the same time.
I think the story you told me about cleaning the hulls of ships, which is where I think you use an exoskeleton.
Yeah, part of it, yeah.
One of the things Kiva said was you can last about 18 months without ruining your shoulders or something like that.
Yeah.
And so if you actually wear this exoskeleton, it protects your body in really important
Well, riveting
ways.
and cutting, vibrating is if you think about it, the average person in the Navy can only do that job 3 to 5 years. And then they typically have arthritis or some other type of problem. So protecting the servicemen and then also shipyards, if you think about that, they're also not super fun jobs. So, and we were just at the Shipbuilders Association event, and their biggest issue is it's not super sexy to work at a shipyard, right? So how do you attract a 22-year-old to want to go and actually work in a shipyard? Oh, they can be a robot operator. They can have a fleet of, and they can use the same glasses that they use to play video games. And now, next thing you know, that 22-year-old's like, I get to play video games all day long? I'll sign up for that. We're really leveraging technology, too, to reframe some of these industrial jobs so that they can attract younger talent. So that, to me, was an aha moment when you've got all these folks that literally are at 30% of their workforce capacity because they can't hire people. They can't find young talent.
I think that's really important because we are, facing a labor shortage in many critical occupations. And so I was just remarking in the morning, which was we've gone from, oh my God, the robots are taking all our jobs, to thank God we have robots for the jobs that we can't find people for.
Yeah.
But let's now flip the switch a little bit and go so that's the Sarcos perspective. Let's go to the user perspective.
Yeah.
Because this panel is titled Investing in Frontier Technologies. What do we as companies or institutions have to do? Like, what complementary human skills do we need to work with these robots?
Well, the nice part is Sarcos has been around for 30 years. We also just acquired another company in Pittsburgh called RE Squared, and they've been around for 20 years. So within our body of engineers, we have people who've been really focused on robotics, probably some of the most robust PhDs in the space, and people who really feel as if robots have a role to play, not to replace humans, but to augment and enhance humans. And so for companies, I think the most important thing is to really ask yourself, what is that standard operating procedure or pain point where I could actually use a robot? How could a robot help me? So one of our partners, their average age in their workforce for skilled labor is 55. That's not sustainable. That's also a super dangerous job. They're removing vegetation around live power lines. People die every single year. So just imagine the ability to say, oh, that person doesn't need to put themselves in harm's way. So look at those and then challenge your team to change the operating procedure. Ask that difficult question. Why not? COVID's helped, definitely for us, to pull that attraction. But in the past, it was that fear of, well, the robots are going to take the jobs away. Not anymore. Humans are still going to be engaged and involved.
So last couple of questions is about your business model.
Yeah.
How do you price this? How do you charge? Is it software as a service? Is it robot as a service? What is it?
It's robot as a service. So unlike, I said some of our peer groups who just sell a component, then you have to go, that'll be about a third of the total cost of implementing in having a robot do a task. We provide the full system. So we provide the software that actually understands that it can do that task autonomously. We have an arm, but we also provide the input mechanism, so you're buying that full package, so you're not having to go out and find people to pick all these different parts together and then deliver it. So we're very focused on providing that full system and solution as a service.
So, when we talked to GM earlier, Kevin Tierney was talking about how the car is now a living, breathing thing because it's no longer, once upon a time was you just bought it and they never touched it again except to fix it.
Yeah.
And now it keeps evolving with the software in it. So when I, let's say as a factory owner or as a shipyard owner or whatever, commission some of your robots, does this robot keep improving with time?
It does, definitely. It is a living, breathing system as well. And that's an important, I think, differentiation where as heavy industrial, I've spent a lot of my career in it. People, you build a factory, you spend $4 billion on it, and then you typically would hire, say, a master black belt to do process improvement, right? But you're hoping that that industrial investment doesn't change over time. With robots, we have the flexibility to do that. We've basically benchmarked, if you think about where robots were, they were hydraulic, right? Super heavy, weighs hundreds and hundreds and thousands of pounds. We're electronic. We go in the spaces that humans go. We're small, we're agile, so we fit in that same type of model from the standpoint of taking kind of an old model in science, and now we've electrified it.
Great. Fantastic. So
Yeah.
I'm going to wrap it up there, but I'm going to invite Meghna back on stage, and I shall now stand off to this side and open it to the floor for questions for either Meghna or Kiva. I'm sure you have questions about AI and robotics.
Yeah, so this is probably an obvious question, but it hasn't come up today, is that what's the range of technologies that you end up using in these kind of bots? So I mean, we talk about AI in general, right? We talk about machine learning, we talk about semantic systems and so on. In your particular case, what's the range of technologies that you end up employing to come up with it? You talked about an integrated solution, you talked about basically a robot
Yeah.
that's doing a job in a very hostile environment. What's the range of technologies?
Well, again, a robot, and we were talking about this when we were talking about talent earlier, is truly one of those that requires every single engineering discipline. A robot does not come to life unless you have mechanical engineers, system engineers, data scientists. We have a lot of PhDs in mathematicians, physicists. We have kinematic folks, so they have PhDs in how the hip works. So for us specifically, robotics is hard. So, when Elon gets up and says it's going to be $20,000, you're like, well, wait a minute. Every link, which is a joint, costs anywhere from $8,000 to $15,000. So unless you have a 2-link, maybe a neck and a hip, okay. But I love the enthusiasm, right? Because somewhere out there's a supply chain person going, all right. Because the lithium-ion batteries we used, same batteries we've used for the last 7 years, the prices come way down thanks to his enthusiasm. So in all the discussion around humanoids, our exoskeleton, we started with a humanoid, right? But the reality is the compute capability is not there yet for a humanoid, and from my point of view, to really be a viable solution for industrial partners. But that hybrid, where you still have a human in the loop, and similar to what I said, we have scientists that all they do is figure out how to do supervised autonomy for certain tasks. So there really isn't a scientist or a technology. The advantage of cell phone, we have a lot of silicon in the robot too. So there isn't I'd say a technological advance that we're not taking advantage of.
Last is a question. I'm going to take this as the last question for this session, then we need to turn it over.
Last Pendarkar, CEO of Score Data Corporation. My question to both of you, both on the robotics side and the AI side, say the personalization side, what checks and balances have you thought about to make sure that the AI does good and prevent it from doing bad?
So
For example, I was just to give you a small example, on the robotics side, I am familiar with some of the robots, exoskeletons being built at Sutex
Yeah.
in Berkeley, and one of the engineers introduced a tiny variation in the signal that went into the exoskeleton, and the person who was testing it, he started,
Doing the jig.
Doing his
Yeah.
rheumatoid arthritis motion, which you were preventing the person from getting.
Yeah.
And likewise to Meghna, on the personalization side, there are so many biases that can creep in.
So I'm going to toss that question to Meghna because I need
Yeah.
to wrap this, and
Okay.
so I'll just take one answer, and then please feel free to continue the
Yeah,
conversation
we
with
can.
Kiva.
Yeah. So I think the area of responsible ethical AI is emerging really fast. Like that was like one of the key things when I was hired. Like I had my fingerprints on privacy things at Target. So when I was going to do this, I was like, we're going to start with a responsible AI team, and I didn't know what we were supposed to do. But since then, I've talked to so many universities, so many researchers, organizations, lawyers, policymakers, to figure out how do we make sure that there are two parts. One is that the regulations are coming, so you need to be ahead of that and avoid fines and all of the PR nightmare. But that's not enough. You have to be like designed for good. Like it's not like don't stay out of trouble is not enough. So you basically, you want to make sure you have model inventory. So every model that your company uses, doesn't matter who built it, you should have model cards or model inventory. So we stood that up. We standardized bias mitigation methods. We had a lot of ad hoc audit process. We standardized that. But in year one of responsible AI, my aspiration is that as we mature that playbook, and we're learning from like Google, Microsoft, all these companies are ahead of us in that. We're learning from them. We are in a consortium with them. So, but the idea is that these playbooks become available for anybody who needs to use it, because it's not just a company thing. We are all going to deal with it. And the other thing I would say is that it's like data breaches, right? Like nobody's above it. But it's like, how do you recover from it quickly also? We have to think about it like that. Like it's obviously avoid it, but you might get hit with it and make sure that you can minimize the damage that it's going to cause you. Because we still don't know enough. Like these are still supervised learning, and AI is in its early days. Despite Elon's enthusiasm or anybody else's enthusiasm, I don't believe that we have really cracked it yet.
Well, thank you so much. This is a very optimistic note to end on, because we all worry about it. But to your point, Meghna, more and more universities now have professors of responsible AI. This was the job title that did not exist 3 years ago, 5 years ago,
Exactly.
maybe. And so you're seeing it all across the globe, and the fact that there are these emerging national and international standards. And I've seen Google's work on the ethics, because they, DeepMind published this paper on what is legit and what is not. And I loved, it's not about staying out of trouble, it's how can we do good with it. I think that's sort of the right question to ask. Of all of the things we're not just AI, but all the things we do with technology, we have to ask these questions, because we're changing the world in foreseen and unforeseen ways.
Absolutely.
So thank you to the two of you. And with that, let me turn the floor over to Tom again.
Thanks for having us.
My
you for
pleasure.
having
It's such a joy to have you.
Thank you.